Good morning everyone. Today's lecture I am going to discuss about in the Laplace transform what is a periodic function and where it will be useful and problems based on the periodic function. To start with, what is the periodic function? The definition says that a function f of t is said to be a periodic function of the period t which is greater than 0 always if f of t plus nt will be f of t where n can take the values of 1, 2, 3 etc. So the examples here will be sin t and cos t. They are the periodic functions of the period 2 pi. So we can say like sin t will be equals to sin of t plus 2 pi. We can observe that 2 pi is one full rotation and it will be in the first quadrant. So if anything, if it is added, we will be getting the same as sin t. And it is a period of 2 pi. So when it is n pi, that is sin of t plus 2 pi, 3 pi, 4 pi and so on. So we will be getting continuously 4 pi, 6 pi, that is sin of t plus 4 pi, t plus 6 pi and so on we will be getting it. Therefore, it will be after one rotation or after two rotations we will get back to the same result. That is why it is a periodic function with a period of 2 pi and so on. These are the two examples, the standard examples, that is sin t and cos t, which are of the period of 2 pi or 2n pi we can say. Here is a theorem, a standard theorem on the periodic function where our statement is only useful for us. The statement says that if f of t is a periodic function of period t, then L of f of t is 1 upon 1 minus e power minus t into integral 0 to the period t e power minus st into f of t dt. This is the statement which we are going to use it in order to find a Laplace transform. We can observe here there is a function f of t is t square where t is from 0 to 2 and f of t plus 2 is f of t for t greater than 2. Find L of f of t. That means here the period will be 2. So f of t is a periodic function of a period 2. That means the capital T will be equals to 2. Now we have L of f of t is equals to 1 upon 1 minus e power minus st 0 to capital T e power minus st f of t into dt. So this will be 1 upon 1 minus e power 2s, because this small t is a period 2, therefore it is minus 2s, where s is same and t will be replaced with 2. And this is 0 to 2 and t square e power minus st into dt. So this is a constant part and this we need to evaluate. So we can evaluate by UV method or by using the Bernoulli's rule of integration, where the Bernoulli's rule says that integral of u v dx or whatever will be equals to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus etc. So how is it means? First function we have to choose by using the isolate rules. U is the first function and v is the second function. Here the suffix represents the integration and the superscripts represents the differentiation. So u into first time integral of v minus u dash derivative of u into second time integral of v plus u double dash into third time integral of v3 minus. You can observe alternatively we are using plus minus and this will continue till u will become 0. So here when t square is there, so first u will be t square, u dash will be 2t and u double dash will be only 2. So this part is a constant 1 upon 1 minus e power minus 2s into t square, that is u is as it is. v1 will be e power minus st divided by minus s, because e power minus st when it is integrated with respect to t, you will be getting minus s as a constant which will be divided. Similarly for the second part, minus 2t into e power minus st divided by minus s the whole square plus 2 into e power minus st divided by minus s the whole cube. And the limits, since everything is integrated, we will have to substitute the limits, that is 0 to 2. These are the limits we are going to substitute. Now this part is a constant. Then when we substitute the upper limit 2, what we will be getting is t square, that is 4 minus of e power minus 2s by s minus, because minus the whole square will be positive, so minus remains the same, and here t is substituted as 2, so that it will be 4 e power minus 2s by s square minus 2 e power minus 2s divided by s cube, because minus s the whole cube will become minus, therefore it will be minus 2 into this part. This is only the upper part has been substituted for all the three. Now the lower limit when we substitute, for the first one it will be 0, for the second one also it will be 0, whereas for the third one it is e power minus st, where t will be 0, therefore it is minus s cube. And this is minus, and already minus is there because of the lower limit, it will become positive. And as a whole we can take the LCM as 1 upon s cube outside. Then what happens is this part it will become positive, and even 2 we can observe everywhere it is common, 2 is taken outside. So 1 minus 2s square plus 2s plus 1 into e power minus 2s, because all these 3 has the e power minus 2s, so for these 3 it is taken, whereas for this nothing is there, so it is only 1. This is how we are going to solve the periodic function. Next problem. F of t is e when t is from 0 to and a by 2 to a, it is minus e. So where f of t plus a is equal to f of t, show that L of f of t is t by s tan h of as by 4. So let us prove the result. Given function is a periodic function of period t minus a t is equal to a. So we have L of f of t is 1 upon 1 minus e power minus st 0 to a e power minus st f of t dt. And here 0 to a, because it's a period is a here, and here also 1 upon 1 minus e power minus as, and this is what. Now this period that is 0 to a is split as 0 to a by 2 is 1, another one is a by 2 to a. When it is 0 to a by 2, the function is e. When it is a by 2 to a, it is minus e. So let us substitute accordingly. 0 to a by 2, it is e into e power minus st dt, and a by 2 to a, when we take, it is minus e into e power minus st dt. Anyway, we can take the common as a constant, that is e. So here it is e power minus st dt, 0 to a by 2, and here it is again e power minus st dt, but a by 2 to a. And we know that integral of e power minus st will be e power minus st by minus s, and the limits are 0 to a by 2. Here also the integration remains the same, but the limits are a by 2 to a. Now let us substitute the limits, that is upper limit and the lower limit. Then what happens? Let us see. You can observe e divided by 1 upon 1 minus e power as, and this is e power minus as by 2 divided by minus s minus e power 0 by minus s. Whereas here upper limit is a, so it is e power minus as by s minus s minus of e power minus as by 2 divided by minus s. So what's common here? We have to observe and we can add it. Here it continues. E by s is a constant, we can take it out. 1 upon 1 minus e power minus as, e power minus as minus 2 e power minus as by 2 plus 1. This is what we will be getting. And we can also write it as a plus b the whole square form, that is 1 minus e power minus as by 2 the whole square. And here 1 minus e power minus as by 2 the whole square, and the denominator can also be written as in the form 1 square minus e power minus as by 2 the whole square. That is like a square minus b square form, by writing this as my e power minus as by 2 the whole square. And this, if we split as a minus b and a plus b, we can write it as 1 plus e power minus as by 2 and 1 minus e power minus as by 2. And one of the term gets cancelled here in the numerator as well as denominator, that is 1 minus e power minus as by 2 and 1 minus e power as by 2. So we get 1 minus e power minus as by 2 divided by 1 plus e power minus as by 2. Now again we will multiply and divide by e power as by 4. What happens is e power as by 4 minus as by 4 and as by 2, it will become as by 4 with a minus sign. Denominator also the same thing it will be. So this will be changed as sin h of as by 4 divided by 2 and cos h of as by 4 divided by 2. Here 2 and 2 gets cancelled. We get e by s into tan h of as by 4. Let's look at the next question. A periodic function of period 2 pi by omega is defined by f of t is e sin omega t 0, and for 0 less than or equal to t less than or equals to pi by omega, for pi by omega less than or equals to t less than or equal to 2 pi by omega, where e and omega are periodic constants. Show that L of f of t is e omega divided by s square plus omega square into 1 minus e power minus pi s by omega, where the period is t is equal to 2 pi by omega. So the solution, we have L of f of t as per the periodic function definition, and here the period is 2 pi by omega, so it is 0 to 2 pi by omega e power minus st f of t dt, where f of t is again split as 0 to pi by 2 if it is taken e sin omega t, and pi by omega to 2 pi by omega is 0. So let us leave this and we will concentrate on this. So we will get e power minus st into sin omega t dt, and this by applying the standard formula, that is e power at sin bt dt is given by e power at by a square plus b square into a sin bt minus b cos bt. So we use this formula here, and then we get as e power minus st by s square plus omega square into minus s sin omega t minus omega cos omega t, where it is 0 to pi by omega. So this will be e divided by s square plus omega square of this into, here this part is taken common. So on simplification, e power minus pi s by omega into minus s sin omega t omega pi by omega minus omega cos omega pi by omega minus e power 0 into minus s sin 0 minus w cos 0. This on simplification we get e power minus pi s by omega minus omega minus 1 minus of minus omega. This on simplification we can take the omega outside, we get 1 plus e power minus pi s by omega, or EW of 1 plus e power minus pi s by omega, and again we are splitting this as 1 square minus e power pi s by w the whole square. So EW into 1 plus e power minus pi s by w divided by 1 minus e, again by splitting. So we can cancel the numerator and denominator, and we will be getting this result. Thank you.